Hi, my name is Edgy. I'm a first year engineering student at the Lausanne School of Engineering. In this project, I will be demonstrated the code I've developed in terms of renewable energy and how we could save money as well as energy resources. So, jumping into my code, I've set it up initial parameters in which I define the principal outcome. Based on my calculations, I found that the principal outcome invested after 50 years was $84,096. Time period of 50 years. Maximum energy saved is 438,000 kilowatts per hour, and the annual saving rate, that's just a 5% annual growth for energy savings and investment. Now, the second block of code I completely used in for the graph to generate the graph. As you can see, all these three graphs are essential in terms of plotting the graph because um, they help from transition. They help define the principal income and maximum energy saved, and based on these two conditions, they generate of an accurate plot of graph based on the two lines. And here I've labeled and organized my graph: X label, Y label, and hold on, so that the uh, plotted graph doesn't fall off. And yeah, I've defined two animated lines, as I said before. One is for investment growth, the second is for energy savings. And this AX limit to ensure that the x-axis, or x limit, I should say, runs in between a value between 0 and a 50, in which I defined years to be 50 after the 50 years. Yes, so the future value will display after 50 years. The investment threshold, um, I will explain that in a bit, but jumping into the for loop, the for loop is a conditional statement in which it runs as long as the condition is true. The for loop runs until it reaches a maximum, or I should say, it reaches the limited value. So, or in other words, I can indicate that a for loop is a repetition control structure that allows the coder to efficiently uh, write a loop that needs to execute a specific number of times, meaning that I need the loop to run for 50 times, so that the repetition of control structure would run 50 times in a row to display each statement in the command window. So um, using the future value formula, future value equals to uh, present value times 1 plus uh, annual saving rate to the power of n, in which n is defined to be as years. I generated these two formulas to make an accurate calculation, and that the statements I prevented here come true after I run the code. So and add points. Uh, this block of code helps me update the plot dynamically, because as I said before, I will be using two different statements. One is the money invested, one is the amount of energy produced. These two uh, lines have to adjust have to have a different animation and adjust based on their defined value. So the if statements, and if statements in MATLAB helps execute a block of code conditionally based on whether a specified condition evaluates to true or false. In my condition, it evaluates to true. And since yeah, this is the maximum of a amount of money reached. Until the money invested reaches $84,000, it would uh, pass $63,000, and as soon as it reaches $63,000, the Arduino board would be triggered, displaying a sound. And I found this idea very creative because engineers or other software companies would be given a signal that their project is working out, so they would be able to make funds for the country. And yeah, that's pretty much it for the code. Yeah, after the end statement, the code ends, and yeah, the command window then displays simulation is complete. So now let's run the function. You can hear the sound. Yeah, and the final part that I mentioned is the learning outcomes. So the learning outcomes is that in terms of soft computing skills, I've learned how to reason about algorithms, trace programs, and use test-driven development, in which I did use artificial intelligence such as ChatGPT for ideas, but then based on my own predictions, based on my own calculations, and the tests ran, I was able to detect where the errors were and how can I make the code run better. And in terms of procedural programming, I've learned fundamental constructs of procedural programming, such as variables, expressions, control structures, and documentation. Programming, I've learned how to write simple programs using an integrated development environments. Computational thinking, I've learned to use computational thinking to solve engineering problems, in which the engineering problem I picked was, as I said earlier, it's how can we save uh, both economically and environmental with the use of renewable energy, in which I found the most attractive and the major issue that our current engineers should focus on. Implementing applications, I learned how to use a computing environment to implement or simulate applications from science, math, and engineering. Besides the math and engineering, I also did research based on science, and that includes renewable energy sources, how much money they produce, how much energy, what the energy corresponds to in terms of economic saving, what that corresponds to if we were to use only renewable energy, then based on our current savings, how would that change? I've used my own assumptions, and yeah, that's pretty much it. I hope you found this video helpful. Thanks for listening and have a great day.